Hello everyone! In this video, I will talk about acetaminophen lab, which we'll be doing this week. Let's talk about over-the-counter medications. In the United States, there are more than 80 classes of over-the-counter medications. Over-the-counter medicines are drugs you can buy without a prescription. Popular examples include cough suppressants such as dextromethorphan and antihistamines like loratadine, and pain relievers like aspirin, ibuprofen, naproxen, and acetaminophen. Acetaminophen is well known as brand name Tylenol. In this week's lab, we will focus on Tylenol, which is acetaminophen. Before focusing on acetaminophen, I want to mention and compare several pain relievers that I mentioned in the last slides. OTC pain relievers can be divided into two types, which is acetaminophen and non-steroidal anti-inflammatory drugs. For abbreviations, we call NSAIDs. First, acetaminophen is not an NSAID drug. Acetaminophen is used for headaches, reducing fevers, and muscle aches, but it is not good for severe pain and chronic headaches. I will talk about acetaminophen in detail in the next slide. Aspirin is used for minor aches and pain and inflammation, but not used for intense pain. Aspirin is an NSAID drug, which means that when you take high dose or for a long term, it can cause gastric effect and kidney and heart damage. Also, it can cause stomach upset, heartburn, and indigestion. Daily use of low-dose aspirin may lower your risk of heart attack or stroke. Ibuprofen is used for headaches, injured muscles, inflammation, and fever reduction, but not used for chronic headaches. It acts quickly and has a lower risk of gastric effect and kidney problems than other common NSAIDs like aspirin and naproxen. Naproxen is used for lasting headaches, inflammation-based pain, but not used for quick pain relief and fever reduction. So when you have chronic headaches, naproxen is much better compared to ibuprofen and acetaminophen. Like other NSAIDs, taking high dose or long-term use of naproxen can cause gastric effect and kidney and heart damage. Like I mentioned in the last slide, let's talk about acetaminophen in detail. Acetaminophen includes amide group and hydroxy group, and you can also tell that it includes phenol group because there is hydroxy group with benzene ring. Acetaminophen is one of the most widely used pain relievers. It reduces pain and fever, but it does not reduce inflammation. Well-known side effect of acetaminophen is that high doses can cause liver toxicity. There are no blood thinning and gastric effect like NSAIDs, so acetaminophen can be prescribed in children and asthmatics. Acetaminophen was first prepared by Herman Northrop Morse at Johns Hopkins in 1878. It wasn't marketed until 1950s. Tragesic is the first commercial medicine contained acetaminophen. Today, its most common trade names are Tylenol and Panadol, but a large percentage of its sales are as a generic drug. In this lab experiment, acetylation reaction is to form an amide from an amine and anhydride. In synthesis of acetaminophen, para-aminophenol has amine functional group, acetic anhydride has anhydride functional group, acetaminophen has amide functional group, and acetic acid has acid functional group. Acetaminophen is formed with byproduct acetic acid by reacting para-aminophenol and acetic anhydride. From this page, let's talk about acetaminophen reaction mechanism. First, nitrogen with lone pair electrons in para-aminophenol has slightly negative charge, so it acts as nucleophile. Here, carbonyl-carbon in acetic anhydride has slightly positive charge because oxygens connected to carbonyl-carbon pull negative charges. So, this carbon is electrophile in this step. Therefore, these lone pair electrons in nitrogen attack carbonyl-carbon and anhydride, and then these double bond electrons move to oxygen. In this step, lone pair electrons in oxygen move to make double bond and eliminate acetate. In the last step, electrons in oxygen on acetate attach to proton, which transfer proton. Finally, acetaminophen and byproduct acetic acid is formed. Let's talk about acetaminophen lab procedure so we are able to actually make it. This acetaminophen is not safe for consumption, so after finishing this lab, you need to dispose of the product. First, we will do reacting mixture and heating. Place magnetic steel bar in a 50 ml aluminum flask. Then weigh about 1.5 gram of para-aminophenol and place this in the flask. By using graduated cylinder, add 4.5 ml of water and 1.7 ml of acetic anhydride. Then heat the reaction mixture with stirring directly on the hot plate using a thermometer to monitor the internal temperature about 100 Celsius. To make stir by stirring, you need to turn on the right dial on a hot plate. After the solid has dissolved, heat the mixture for an additional 10 minutes at about 100 Celsius to complete the reaction. In this page, we will talk about how to isolate crude acetaminophen. After completing the reaction, remove flask from the hot plate and allow the flask to cool to room temperature. Cool the mixture thoroughly in an ice bath for 15 minutes and collect the crystals by vacuum filtration on a vacuum funnel. To collect product still in the flask, rinse the flask with about 5 ml of ice water and transfer this mixture to the vacuum funnel. Dry the crystals for 10 minutes by allowing air to be drawn through them while they're remaining on a buccal funnel. Weigh the crude product and check the range of the melting point and the color. Use the Chem machine to check the range of the melting point. Calculate the percentage yield of crude acetaminophen. In this page, we will talk about how to recrystallize acetaminophen. Place the crude acetaminophen and 1.0 gram sodium dithionite in a 50 ml Erlenmeyer flask. For recrystallization, you need to add small portions of hot solvent, which is 50% methanol, until the solid dissolves. You need to try to add hot solvent as small portion as you can. When all solids are dissolved, allow the mixture to cool slowly to room temperature. When the mixture has cooled to room temperature, place the flask in an ice bath for at least 10 minutes. In this page, we will talk about yield and melting point determination steps. Weigh the crystallized acetaminophen and calculate the percent yield and determine the range of melting point of the product. And then compare the melting point and color of this final product with that of the crude acetaminophen. Before finishing this video, I want to remind you about safety. Acetic anhydride is corrosive, which can cause skin burns and irritation of tissue. So if you spilled, you need to neutralize with weak base. Then clean neutralized spill with water and paper towels. And if you spill on your skin, you need to thoroughly wash with the water. You always need to wear gloves and goggles in the laboratory. And you need to dispose of liquid waste in jugs and solid waste in pails. This acetaminophen lab is for comparing crude acetaminophen and recrystallized acetaminophen. You will observe the color and the range of melting points of each. By comparing the range of melting points, you can figure out which one is the purer compound.